Okay, so higher when we put something into a quadratic into completed square form, we're going to have a number in front of the x squared. And that means we need to take a slightly different approach. We could take an approach like National 5, where we kind of half the coefficients and work with that. However, it can get a bit cumbersome and it can be difficult to obtain marks in an exam when doing it that way. So what we're going to do is we're going to take a slightly different approach. So our completed square form takes the form a bracket x plus b squared plus c. And you'll be given that form in an exam question. So the first thing we're going to do is we're going to multiply out that expression. So when I multiply out x plus b squared, I need to remember that that is two brackets that says x plus b. So if I multiply that out on its own, without the a and the c, thinking about that, I'm going to get x times x, which is x squared. I'm going to get b times x twice, so 2bx, and then I'm also going to get b squared. Then if I multiply out by a, so I'll get ax squared plus 2abx plus ab squared plus c. So we're going to use this expression here to help us put 3x squared plus 12x minus 11 into completed square form. So what I'm going to do is I'm going to equate them. I'm going to make them equal to one another. So I'm going to say that ax squared plus 2abx plus ab squared plus c is equal to 3x squared plus 12x take away 11. So now I'm going to do something that's called equating coefficients. So coefficients are numbers that come in front of something. Okay, so we're going to take it one at a time. So the first thing I'm going to do is I'm going to equate my x squared coefficients. So I'm going to take whatever's in front of x squared on this side of my equation and whatever is in front of x squared on this side of my equation and make them equal. So that's telling me that a is equal to 3. So I've got an answer straight away. I'm now going to do it again, but this time I'm going to equate the x terms. So in front of x, I've got 2ab, and on this side, I've got 12. So I'm going to say that 2ab is equal to 12. And then lastly, I'm going to equate the constant coefficients. Okay, so not in front of any letter, just the constants on their own. So on this side, I've got ab squared plus c, and on this side, I've got negative 11. So ab squared plus c equals negative 11. So because I know that a is equal to 3, I can substitute that into here. So 2 times 3, b equals 12. So 2 times 3 is 6, b equals 12. Divide by 6, and I get b is equal to 2. Now that I know a and b, I can put them into my last equation here. So I'm going to have 3 times 2 squared plus c equals negative 11. So 2 squared is 4, times 3 is 12. And then if I take away 12 from both sides, that's going to give me negative 23. So when I write this in completed square form, that's going to give me 3x plus 2 all squared, take away 23 by replacing a, b and c with the numbers that we've worked out. All right, so let's just try another one. So again, I want to put this in the form x plus b squared plus c. So if I multiply all that out, I'm going to end up with ax squared plus 2abx, sorry, ab squared x, no, just ab, plus ab squared plus c. And we're going to let that equal 6 plus 4x take away x squared. So if I equate my x squareds, I've got a negative 1 on this side and I've got an a. So a is equal to negative 1. If I equate my x's, I've got 4 equals 2ab. And if I equate my constants, I've got 6 equals ab squared plus c. So I'm just going to make this 2ab equals 4. I know that a is negative 1, so 2 times negative 1, b equals 4. So negative 2b equals 4. So if I divide by negative 2, I get b equals negative 2. Substitute both of those into here. So a is negative 1, b is negative 2. So negative 2 squared is 4. That'll give me negative 4 when I multiply by negative 1. So c will equal 10. So if I write this in completed square form, I'm going to have negative 1, or just negative, x take away 2 squared plus 10.